You're probably going to use it every single day you do calc from here on out. It's really an important part of the derivative, so make sure that you pay attention. Okay, so first we want to define composite functions, which you've seen before. So it's pretty much a function inside another function. So right here we say this as f of g of x. F of g of x. We've also seen it written as like FOG, but it's more common to write it like this, especially in calculus. But pretty much you're taking a function, you're putting it inside another function, right? So like back in the day, we'd have like f of x equals x squared, g of x equals 2x, and then f of g of x would be like 2x squared, which is 4x squared, right? So that's where it came from before, back in like pre-calculus and any classes you took before. So here with calculus, we're going to use it for the chain rule. So first, let's just separate the f and g's, like separate the functions. So here we have sine of x squared. So we have, let's see if I can do different colors. We could do f of x equals sine of x. And then we have g of x equals x squared, right? And so we have the x squared going into this x. So similarly here we have f of x equals square root of x, and then g of x is whatever's in that square root, so ln of x. And then this one's a little trickier. This one is actually 3 functions. So this is f of g of h of x, right? So the first guy on the outside is cosine of x. And then what's inside of that is sine of x. And then what's inside of that is a 5x. Do I have another color? Okay. Right, so we're just lots of composite functions, putting things inside of other functions. Okay, so the whole point of the chain rule, which is the derivative of a composite function, is we have f prime of g of x times the derivative of g of x. Right, and so that looks really icky, but pretty much this is saying, right, take the derivative of the function, like normal, then multiply by derivative of the inside. Okay, so what does that mean? Obviously, it makes more sense when you have an example. Okay, so we're going to start here. We have our f of x. Well, they already have f of x, so just sort of ignore that, right? We're going to use, let's just say this is like, well, I don't want to say f of x twice, so I'm just going to have the inside guy. So I have f prime of x. So I'm saying the derivative of the function like normal. So this is power rule. 4x squared minus 5 to the third times the derivative of the inside. So times 2x. That's it, because the 5 turns to 0. All right, so to be more clear, This is power rule for x squared minus 5 to the 4th. Right, we just bring the 4 in front. Whatever is inside is the same. And then we do the power minus 1. And then this right here is the derivative of x squared minus 5, which is the inside of the power rule. So you pretty much do what you know how to do, which is a normal derivative, and then you deal with the inside later by taking the derivative of it and multiplying it. So if I was to try and find the actual to simplify f prime of x, we would have, we'd multiply this 4 times this 2x, 8x times x squared minus 5 to the 3rd. This is probably like the simplified version that I'd want. Okay, so this is just going to be very practice heavy, lots of different cases. So for number 2, we have g prime of x. Actually, before we start, I'm going to rewrite this. So we have 4x minus 3 to the 1/2, right? Because square root is 1/2. So then it'll be easier to take the derivative. So we have g prime of x equals 1/2 4x minus 3 to the negative 1/2. So this is our normal power rule. And then we times it by the derivative of the inside. So that's just 4. Right? So if we were to simplify this, we could do the 1/2 and the 4. So we have 2. And then this goes on the denominator because it's negative, square root of 4x minus 3. Okay, so this one's a bit trickier because it's multiple chain rules. So it's like chain rule and then another chain rule. So another way, the tricky thing with sines and cosines, we've actually done this before, is you could rewrite this as sine of 5x, that whole thing squared. They just like to put the square here because they don't want you to think that the 5x is being squared, right? They don't want you to think that this is saying sine of 5x squared. They want you to know that it's 2 sines times each other. So whenever you see like a trig function raised to a power of something, they're going to usually put it in front of like whatever's in that parentheses. So knowing this now, we can do our chain rule. So first we have 2 times sine to the 5x. And then we need the derivative of this because we took the power of it. So then the derivative of sine is cosine, derivative of sine of 5x is cosine of 5x. And then since this isn't just an x in the middle, we have to take the chain rule again and multiply it by 5. So let me just add some notes in color, right? So this is power rule of sine 5x squared. This is chain rule. The derivative, I'm just going to say deriv, of sine of 5x. And then this is chain rule again. Deriv of 5x. So if I was to simplify this in the end, I'm just going to put it above because there's not that much room. It's just 10 sine 5x cosine 5x. So just remember to simplify your things, right? Because we're going to usually have like constants at the end of our chain rule. And eventually you'll just get used to this. You'll just know. You'll be like, oh, there's something in the parentheses. I'm going to have to take chain rule at the end. Like, I don't need you writing down these rules in your homework or test or anything, but it's just right here on our notes so that you know, like, where this is all coming from. Okay, and then for 4 and 5, we can do chain rule again. So they're meant to be the same. They're just showing you two different ways of doing it. So we're going to have, if you remember that the derivative of ln of x is 1 over x. So we have the derivative of, we have y prime equals 1 over x cubed times 3x squared. So using our colors again. So the derivative of ln is always 1 over that. And then chain rule. Derivative of x cubed. Right? So if we were to simplify this, we'd have 3x squared over x cubed, and this would cancel out, so we just have 3 over x. And then for 5, they wanted to show a different way. So this is actually from pre-calculus. Pre-calc, vocab. We have power rule of logs, right? So I could actually rewrite this as 3 ln x, right? We could pop the 3 in front. So that's why some of you were pretty good at the power rule when we did derivatives, is because you saw it last year when we did logarithms. And then this is actually a much easier thing to take the derivative of. We just have the 3 in front, and then ln of x is just 1 over x. So that equals 3 over x. So there's a few ways to do it. Chain rule, sort of like with when we were learning the product rule, like sometimes you could multiply it out, like do like the box method and then take the power rule, or you could do the product rule. Okay. All right, so this next one, we can see that there's a quotient, so there's going to be a quotient rule. So the first part of this, we're going to do our power rule. So we have 3 times the quantity t squared plus 1 over 2t minus 5 to the power of 2. That's just your normal power rule, and then we need the derivative of this chunk inside. So we're going to do our quotient rule. I always like to say low d high d low in my head. So we have low, which is the thing on the bottom of the derivative, times the derivative of high, d high, which is just 2t, minus high, t squared plus 1, d low, which is just 2, all over low squared, 2t minus 5 squared. So low d high minus high d low all over low squared. So just to be, again, really explicit, this is derivative using power rule. And then this is chain rule, derivative of quotient t squared plus 1 over 2t minus 5, right? So this fun thing about calc is that everything just builds on each other. Okay, so you will probably have to simplify this, but it doesn't need to be crazy. The tricky thing is, like, you could be in like a test, you could be in like a college course or taking the AP class, and they'll be like, what is this? And it'll be multiple choice. So it's just a matter of recognizing like which of the multiple choices matches your answer. So something that you want to do is you'd want to multiply out this numerator. So I'm just going to do it right here. So we have 4t squared minus 10t minus 2t squared minus 2. So remember the negative distributes. So it's a minus 2 at the very end. So on the numerator we have 2t squared minus 10t minus 2. And we'd want to pull out a greatest common factor of 2. And we'd have t squared minus 5t minus 1. So this is what our numerator should be after simplifying. And then to put it all together, we would have, so this is the blue part, 3 times t squared plus 1 squared, 2t minus 5 squared. So I sort of separated it into the numerator and denominator, but they're both squared, like in the original. And then our red part is 2t squared minus 5t minus 1. And then our denominator is the same. So I'm just going to put the colors so you can see it's the same thing. Just to not get lost in the sauce. I know right, this is going to be this and this. Right, that's our numerator. And then our final simplification would be 6t squared plus 1 squared, t squared minus 5t minus 1 all over 2t minus 5 to the 4th, because we could see that our denominator, we have the same factor. So this is probably like the best way to simplify it. It's sort of like in factored form. But obviously this is like the calculus part, like doing the derivative and the chain rule and the quotient rule. But you're going to have to simplify it, especially if a question's like multiple choice. Or, I don't know, depending on what teacher you get in your future, whatever calculus teacher, however they want it. You just want to have these skills. Okay. So for number 7, you can sort of see like we're going to plug in a number, right? That's what's going to happen. So we're doing the same thing, but we're going to plug in a number. So let's rewrite this as 2x, 1 minus x to the 1/2. And we're going to do product rule first. And then inside of that, we need a chain rule. So we're going to do the derivative of the first times the second plus the first times the derivative of the second. So this would be 1/2, 1 minus x to the negative 1/2. And then, just to write it to make it look prettier, we're going to have 2 square root of 1 minus x. And then this 2 and this 1/2 cancel to 1. So then we just have plus x over the square root of 1 minus x. Oh, and then we forgot something. Okay, so here we took the derivative of it. We also need to do this chain rule right here. So we need a -1. So this is a minus. See, it's really easy to forget, right? Because we can't just take the power rule here. We have to also take the chain rule. So let me try and label that. Or this right here. Power rule, derivative of 1 minus x to the 1/2. So right here. And then this -1 right here. Chain rule, derivative of 1 minus x. Right, so it's -1. Ooh, tricky. All right, and then let's plug it in. So we have 2, -3. So this is just going to be the square root of 4 minus -3 over square root of 4. So square root of 4 is 2. So we have 2 times 2 is 4 plus, because it's minus a negative, 3 over 2. So to add fractions, we need a common denominator. So 8 over 2 plus 3 over 2 is 11 over 2. So this one's tricky because it involved product rule, then chain rule, and then fractional exponents, and then just remembering at the very end how to plug in and not forgetting our algebra. Okay, so for these, I'm gonna write it before we put in our 4, and then I'm gonna do it after. Okay, so for this one we do our power rule, so 2g of x, and then we do our chain rule. So this is the power rule, this is the chain rule. It's a little harder when you're just using, they don't give you an actual function, so I have to like physically write g prime of x. So this one I'm going to rewrite as h of x to the 1/2, and then I'm going to take the derivative, power rule, chain rule. And then here we have power rule h prime of g to the x. So this doesn't change. It's still g to the x on the inside. And then we have g prime. So power rule. Well, that's not even a power rule. This is just derivative. Because we don't know if h prime is a power like type derivative. All right, and then we just get to plug it in. So 2g of 4 times g prime of 4. So that's 2. G of 4 is 3. G prime of 4 is negative 2. So 2 times 3 is 6 times negative 2 is negative 12. All right, let's finish this up. So we're going to plug it in. So we have 1/2 of h of 4 to the negative 1/2 times h prime of 4. So that's 1/2 1 over the square root of h of 4, which is 9, times h prime of 4, which is 5. So that's 1/2 times 1/3 times 5 equals 5 over 6. Alright, so this one's a little tricky, this last one. So we took our derivative, so now we're going to plug in our 4. So we have h prime g of 4 times g prime of 4. Okay, so g of 4 is 3. So h prime of 3. And then g prime of 4 is negative 2. And then h prime of 3 is actually, we're going to use this first row here finally, because our input is 3 instead of 4. So our input is 3, so h prime of 3 is negative 3. So negative 3 times negative 2 is positive 6. Alright, so you can see I already did 2 of these sample problems. You have the odd answers, so this is really important. You can clearly see that the chain rule involves everything. It involves power rule, it involves cosines and sines and ln's. It involves product rule, it involves quotient rule. So soon when you take the derivative, it's going to just almost be guaranteed that you're going to use the chain rule.